Right.
Semua orang dah tahu kena buat apa kan. Yang itu first yang kita kena buat, we have to do a data sheet about the COVID-19 vaccine. But based on the instruction of doctor, we have to mainly focus on the characteristic of that nanoparticle, right?
Backup.
So, how to start? You know how to start?
I don't know.
Maybe kita introduce dulu ke? Macam Lex ke?
Ya,
Tak tahu.
boleh juga.
Can I first introduce yourself?
So my name is Kari Asu. Nak cakap English ke Melayu?
English.
So basically, like doctor said, like he outlined a few things for the characterization, like particle size, FTIR, encapsulation efficiency, and zeta
Morphology.
zeta apa dah zeta
Potential.
zeta potential. So like we basically have to talk about that in the our data sheet. Like for data, we should find like a data figure for the zeta potential, FTIR, and the data should be like coherent with the nanoparticle we are using. The solid lipid nanoparticle. The lipid nanoparticle and the drug we are using is the mRNA based on the COVID-19 vaccine.
For me, I have read through some journal. I think there is some difference between for the characterizations of the nanoparticle which encapsulate the mRNA molecule and the drug. So there are different methods for both. So I think we have to find for example for mRNA nanoparticle, and we can know what characteristic we need to include to our data sheet. But for sure, I think for the particle size like DLS and FTIR is common one for all the particles, because we need to generate the lipid nanoparticle first, right? And actually, I'm not sure because the doctor focused on the COVID-19 vaccine, right? Vaccine with using the lipid nanoparticle. And I'm not sure doctor want us to find out what is the component of this vaccine, like, because I searched online, there are many, like many functionalization, like the components of the lipid. There are many type of lipid. We're not sure what lipid is used for COVID-19 vaccine, right? Because I can't search it, like the Pfizer BioNTech vaccine, we're not sure how they make it, how they construct this mRNA nanoparticle. So this one we have to discuss. Either we just do it based on our imagination, or we just search an example from online and show it in our data sheet.
I think the reading we just do it hypothetically, maybe.
Yeah. So I think we just search some relevant data and explain a bit and include in our data sheet. So based on for morphology data, I think is about the TEM, right? The
PSM, how the structure look like, the surface.
Okay. So how do you think, Harsha, what other thing we need to include inside?
I think we just have to decide the number. I think the number for our data, for the size. We have to decide for the size. The percent of encapsulation, morphology.
Like I think like a lot of journal was listed in the group, right? I think we can use all that, like it got all the information, like most of the zeta potential, the loading efficiency, everything. So like we just have to like theoretically, because like there's no previous study, right, on the COVID vaccine, there's no like data about characterization. So we
The
just have
details,
to
yeah.
assume it like, or if the characterization will be like this. So, and like the journal like previously mentioned in the group, I think got all the data required. We can include it.
Maybe approximately lah.
Yes, yes.
I agree because like based on the journal that doctor gave to us, the Pfizer one it's only include the particle size for the nanoparticle, right? So
Yeah.
maybe but doctor mentioned in the discussion we have to make up the data. So I think it's okay if we just search other journal and then include from other journals data into the data sheet. Mm,
Good.
and one more thing, I think the content maybe doctor just state the content as example. Maybe we can like change accordingly. I mean like for FTIR, nanoparticle
Yeah.
size, maybe we can change others to other what essay, right?
Yeah,
Not exactly
yeah.
follow the one that
Yeah,
doctor
yeah.
give.
Because
That is
each
true.
one is
But
specific
Jawi's
for
group,
mRNA. Yeah.
Jawi's groups, they just make up the number and then they insert into the graph. I already asked their group, they just do it like
Also,
that.
they create the number
Yeah,
themselves.
yeah, they create a number.
They make the
Oh,
graph out. Okay.
They just want us to see how we represented data in the graph, like zeta potential, DLS, how we describe it. So they just make up the number.
Oh.
I think we can do that too, as long as it
I
seems
think
logical.
we can
I
find,
agree.
yeah, or we can just take the picture from the journal about the mRNA nanoparticle. They should have or have the DLS graph like this
Yeah,
one.
yeah,
Just
yeah.
we can just take it as a example. Yeah. And then anyone have other opinion about the content of our
Alia,
session?
Aisha.
I think in my opinion for the particle size, you can just take from the journal that Dr. give because it's already there.
Yeah.
But for the things like morphological data and FIR, we have to make up the data because it's not in the journal. We can use the journal that it's other journal that's already in the group.
We just have to refer kan
Uh-uh.
the data in the group.
But I'm confused about the morphological. That one we use what instrument?
TM,
Like
I think,
using
to
Yeah,
know
I think
the
TM too.
size, yeah, and the shape is round or the surface, how it look like. Yeah.
oh okay. So we just take other picture from other journal and
Maybe.
then claim it as
Later we just go through the journals that we share in the group. We just go through and we so that we can have a general idea what to include to our content. Yeah.
maybe we can
Oh,
discuss on what content we want to
yeah,
include in the
yeah,
data sheet today.
yeah.
So maybe
So
waiting, can you open the journal so we can
okay, I just share the journal
share
that
screen?
I sent just now.
The last one I think. The
Yeah.
latest.
This one, I think what is that? This one is design. Oh, this one is the about the COVID-19 vaccine
One.
also, but the journal that Dr. Shea is about the cell and pricing RNA, right? But this one
Yeah.
we use the HFC conjugated receptor binding domain mRNA, means that the mRNA that used in this journal is quite different now from the SM and RNA. But I think we can just took it as a reference because this one is semi also use the mRNA to be encapsulated in the lipid nanoparticle.
Yeah.
So from here I have highlight this one is what this one is TN image.
TEM.
This one we can include this in the morphology data, and this one is about the size and the PDI. This one is the construction. I think we can include the picture of this, the construction of this nanoparticle. What's inside? This
The
one is
morphological.
morphological. We can include the picture of this. This one I have highlight some important info. This one for these journals we can get the data of about the PDI, DLS, TM, and
Efficiency.
efficiency. The encapsulation efficiency. I'm not sure.
In Jawi's group, they took the methods for the encapsulation efficiency and put it in their description.
Oh.
And
Wait, let me show you the group.
this one is used I think it's the in vivo expression efficiency. It means
I think like Doctor one the loading efficiency. I think this one is same different.
Loading efficiency.
Like how much drug during the process of synthesis.
This one is done in vivo. It means I use the luciferase expression. You will give the color right when insert in the red, and if the mRNA or express, we will cause the luminescence, so we can see the color here. This one is the
like how the drug is. The one Doctor one is like the encapsulation encapsulation efficiency. When you synthesize the drug, you can calculate the how much drug is inside the nanoparticle. I think the Hasha's first journal got similar, like got that thing, the data.
Hasha journal.
Hasha's
I'm not sure whether I got.
First one.
First one.
I didn't download your journal.
Cuba try tengok.
Which one? This one, right? This one, it use a drug, DOS.
I use drug, but
it also use the lipid to encapsulate it. This one, right? How to make it?
Try see if you've got table. That's the table. I think got the encapsulation efficiency.
The table is look like this.
You got to share the screen, Matty?
Yes, I am sharing. Can you guys see my screen?
No, tak ada lagi.
I can see a screen, but it's not moving.
Yes, not moving.
Can see now?
Yeah.
Yep. This one is the journal that Hasha shared in the group.
I think the first table. I got the encapsulation efficiency.
This one. Waiting atas lagi.
So like they use like a lot of formulation and they see the
third page.
The best one the best got the best result
Third page waiting.
This is the table table 1.
This one is the formulation, right?
If you see at the end, right, there's an encapsulation. I think PDI, water, the EE. That's the encapsulation.
They got all the reading.
I thought this one is for they want to see how much your components like something like optimization, like the formulation, how much you put the lipid, how much you put a surfactant, water surfactant, and you check the zeta potential and the size and see which formulation give you the best nanoparticle.
Yes. Like if you like we can use the data like for the efficiency and entrapment from there
You just
yeah. I share you. I think this one is same like you can see the example here is wait I got share one journal that study about the formulation also. Means that what type of lipid they use and how much they put the lipid and check about the data. Let me share. This one. You see this one you see there are different color here, right? This one is DDA and DOTAP is the lipid they use. And interior exterior is means that they put the interior side, they put the mRNA inside, and exterior they put the mRNA outside attached to the outside of the nanoparticle, and they see the efficiency, like which one give the best size and the PDI. I think it's same like this one, right?
Or like if you say open the first journal, the Hasha, I think like you don't understand the encapsulation efficiency, right?
Yeah, quite confused.
Open the first like Hasha, they got the formula
Third
or the
page.
first page I think.
First
Go to
page,
first page. Here.
here.
More below the drug loading and the there's a one formula there.
I did one just
Here,
one.
here.
The
More
drug.
above.
Which one? I can't here.
Above.
Ah,
There.
efficiency, initial drug.
That's the entrap term, the efficiency for the drug is to investigate how much drug is loaded.
Oh.
Basically, if you can see in our group WhatsApp, I've sent maybe the example of other group. They are doing the description like that. I've sent in the WhatsApp group.
The amount of content in nanoparticle is investigated using HPLC and UV detector.
I don't think like the method. I think like we just have to present like the table only, like the entrapment efficiency, like 99%
I want to
like that.
see the result.
This one is
I feel like this is for the this one is for the DLS or size everything.
Yeah. And this one is the morphology.
Morphology.
FTIR.
This one is FTIR.
FTIR.
The one that
in vitro release profile.
I think don't need. I think this one. For the like loading efficiency, there's like it's not that important. We just have to know like the what's the percentage. If above the 90% is like good. I mean a lot of drug is encapsulated. It's just that only that.
Okay, in vitro. This one is not. So what is the result for just now? The method is shown in. So how we going to present the data about the encapsulation efficiency?
I think like just the table is enough. Like loading efficiency, like how many percent is enough, because it's like a calculation. Is based on you calculate how many percent drug is there.
Okay.
It's not like a figure thing or everything. It's just like the calculation and numbers.
Okay, we can just put that one put that one for. Okay, so encapsulation FTIR. We see the where I go to. For the size we can just differ here The size I think is, I'm not sure what is the size for. Size about, I think it's
About 100 nanometer.
yeah, because here it use different lipid.
So it has different averagely? We don't know.
Yeah, the average weight, no.
The mean size of LNP was less than 100 nanometer in diameter. This one is the mean size.
Yeah, we can just take the average, the average.
100 nanometer. So
Mm.
the before,
I think this one is not relevant. For this journal, this one you can just go through lah. This one I think it explain about the component of difference, like the components of the lipid nanoparticle. You can just go through for your understanding. But for the design, for the construction of the, otherwise we can just use this figure lah. I think can just use this figure, which is the mRNA is encapsulated inside the negatively charged mRNA you see here. Yeah. Okay.
and then the we just
Yeah.
take from the journal.
And the lipid is positively charged, so it can encapsulate the mRNA.
Okay.
For the size, we can just take the average, the average size. And this is the
So the size we are going to present in what form? DLS?
DLS, yeah. Because this graph, it compare different lipid, right? So if for us, we just take one DLS graph.
So before the after this one is before or after the encapsulation?
We have to compare,
I
right?
think
Before and after.
Yeah.
Yeah, to indicate that.
according to the video, yes, we have to compare.
Yeah.
Before, right?
Yes.
So
If based on the Pfizer paper, it stated that it's approximately 75 nm after the encapsulation
Oh,
70.
yeah. Okay.
with less than 0.1 PDI and more than 90% EE, encapsulation efficiency. So I
Yeah.
think for the size, maybe we can refer here. Just before the encapsulation, we make up je lah kan.
Okay. So we just
Smaller.
follow just now for the Pfizer one.
And then for EE, we have to construct the table, right? But here, it stated more than 90%. So maybe we just,
Take
I
it from
don't
the
know. We have to like compare or just do one calculation with more than 90% efficiency.
Efficiency means the encapsulation efficiency.
yeah.
Because here already stated more than 90%. So do you guys think we have to like do few comparisons or just one with more than 90% and then we just
Do
state
the
at the description?
I think we just do the we just take the percentage only.
Yes, because like we are like
You know
this.
the before procedure of the efficiency encapsulation, right?
Because in our data sheet, right, we have several sections, like the first section, we can have a main title like this, the physical chemical characteristic. For the example,
Yeah.
here, the first section is this one. Then the content will include the BDI, DLS, and the morphological DM. Then the second FDIR is, I'm not sure.
FTIR, maybe we can refer to Kalai's journal, because
I think Hasha, your journal is okay, Hasha, because like it mentioned like the three type, the one with drug, the one without drug, and the with the nanoparticle, everything. It got three image, like we can compare it with Hasha's journal.
Okay.
but we have to change the what? Change the
But
type
the
of the
FDIR, right, because the functional group is different for mRNA, maybe difference for the reactions between the mRNA and the lipid. Is it correct? I'm not sure if is it some same for the drug, and I can't find.
Because like there's not a lot study about mRNA drug.
Yeah, I can't find FDIR figure here.
So like
we just
normally the FTIR we usually like they use FTIR to like confirm like the
function.
drug is successfully inside the nanoparticle or not.
Yeah.
I don't think like we should like go more toward like the what functional group present in the mRNA like that. It'd be confusing, I think.
Or we can just try find some more journal regarding the FDIR, see whether we can find the FDIR diagram for the mRNA nanolipid particle. If we can't find it, we just take the example from the Harsha and we just craft ourselves, because I can't find any. There is no data about the
FTIR.
yes.
So it's okay, we just find it.
Yeah. We can just search out more info. So
we just go through one by one for the content.
yes, we can. But we have discussed those, right? Like with the categorizations, we already have the info about the particle size, PDI, tertiary efficiency.
So now we have 4 content.
Yeah, 4 content. So first for size particle, so we do it in DLS. So before the size before the encapsulation, we
This one
decide
we
for
can just grade ourselves because we know the after is 75 nanometer. Just now the
usually how much it changes.
Uh,
I don't know.
I don't know how much.
Maybe we can make it 60 or 65.
50 or 65? 65 maybe?
65. Yeah.
Is it? 65 is it kind of logic, right?
Yeah, I think so.
So, for encapsulation efficiency, we took any number.
As long as it's more than 90,
Ah,
90%.
it's above 90%. So we go for what number?
Uh, this one.
Can you show the formula just now? I think we have to calculate.
Waiting.
Yes.
Can you show me the formula just now for encapsulation efficiency?
Entrapment efficiency and drug loading. They measure like initial drug amount minus free drug amount over initial drug amount.
Initial drug amount as in size, right? Like the same as PDI, or
No, this one is like
or
during the
is it like
synthesis.
MT?
For example, during synthesis, you are using five certain amount of gram of drug. Then the free drug, during the synthesis and after the synthesis, how much you get? Then you get like if you get all the value from the HPLC, and you can calculate the entrapment efficiency. So like for this, like we are doing, we can just mention like in the table the entrapment efficiency is like above 90. Any value, maybe 95%, 99, 98%. We just mention like that. So we just like say like this like lipid nanoparticle have a good entrapment efficiency. I think it's enough like that.
There is
Like
enough.
no need to go through like the formula that much. Just mention like 19 above 95, like 98, and just say like for the description we can just say like this formulation have a good entrapment efficiency since it's carrying a lot of drug. Like that only I think is
And
enough.
another one, you can see here. I think for mRNA, it may got another method to measure the encapsulation efficiency. You can see the formulations of what RNA was translated in this cell is this one is measure about the translation efficiency. They use the RNA as
RNA.
yeah.
What's the transfection? I don't know what's this.
You see the exogenous mRNA was added to determine to determine whether what formulation can have a high can protect the mRNAs for degradation. This one is considered one kind of efficiency, or this one is a different thing.
I think different. I think it's
Transfection is like transform, right? Like into something. So
This one
maybe this one,
And minimal
or this
degradation.
one when the drug is already in the body, and then how much it will like degrade.
Oh, it means
I
that
think
how
because
much it release
transfection.
the RNA to the body, to the cell.
Yeah,
Maybe,
kinda.
Okay. Yeah, I think this one is different thing.
maybe we can just follow the previous
For this
one. Mm-mm.
So
But like Kak Lai say, we just mention no need to like calculate.
yeah.
Yeah, because we don't have the data for the calculation. This one they don't mention in the journal. I think the HLPC all that is only in thesis.
So are we going to state the method we use?
No need. I think like just put the table. Just say the entrapment efficiency. What's that? Enough, I think.
You can see the thing that Harsha share in the group, the encapsulation efficiency, yeah, is same like total mRNA minus free mRNA over total mRNA. We can use this formula lah, just like same like drug. Just we replace the drug with an mRNA.
mRNA, yeah.
Yeah, you can just
Because the mRNA is the drug.
yeah. So next, for FTIR, we still not sure, right? Because we don't have the relevant information regarding the FTIR of lipid nanoparticle.
Waiting, can you open the Kalai's journal? It got FTIR graph.
Which one? Caroline Journal? Got share in the group. Ah, yeah.
Got.
Yeah, I open now. This one, right? FTIR.
Waiting, I can't see it.
Huh? Can't see.
Cannot see it. I think didn't share. It's not moving.
Can
Yes.
see now? Ah, yeah.
Can.
FTIR.
Yeah.
Which one?
Atas lagi tak silap. This one.
I think maybe for the size we can use this graph, right? This one like the graph like Dr. One.
Yeah, this one.
For after.
This one side.
Maybe that one.
Yeah.
See?
This is the graph like Dr. One, I think.
I see we can use this one.
Yes, and the zeta potential. This one.
What happened?
Undo. Okay. Zeta potential, we can use this one also.
FTL, I'm not sure. Like, I feel like the FTL was like Harsha's. The result should be like the Harsha's journal one.
Yeah,
like
but we're not sure what are the peak for the mRNA and lipid nanoparticle. I think it's different thing. We should identify the peak, right? The functional group.
The PA space. Yeah. We need to know the functional group.
Yeah, the
first,
interaction between the mRNA molecule and the lipid nanoparticle. That's why we can't. Maybe we need to search for other journal. Maybe not for COVID. Maybe for other, we use the mRNA and the lipid one. We can see before that because I have not enough time to search for other journals. So maybe we can try to search for other journal. see whether we can find it. If we can't find it, we discuss later how. No here, not included here.
So basically we put the zeta potential and size.
Yeah, we can defer here. These two graphs. I think it's roughly is like this. I think next week, I think we can divide tasks like maybe one people go for explain about the particle size and another people explain about FDIR. Yeah, so because I think no much time for us, right? Saturday night we have to come out with the data sheet
That's sure.
and we have to design it.
Divide it equally.
Yeah, you can divide the task and everyone go to search for the relevant data maybe because these journals are mainly me and Harsha and Kalai share, right? So if you can go through other journal, then maybe got other more we can get more details information.
Yeah.
I have a question like for the size, right? Should it become big after the nano formation or what? Because like for the size, we can see the lipid nanoparticle is smaller. Then with the mRNA, it become bigger.
Yeah, it's
Yeah.
supposed
It should be bigger.
yeah, it should be bigger.
Yeah, it's bigger here. You can see here.
I mean like it should be because like my understanding like if you make it nano, right, it becomes smaller, right? I'm a bit confused about that. Should it bigger or
Oh,
should it become
you see
smaller?
the dash line here is just a nanoparticle, right? But when you encapsulate that, add insert the mRNA inside, you sure it become bigger.
Should be bigger.
Should be bigger.
Right, okay.
Yes.
I'm a bit confused about it.
So we just divide the task in the group maybe?
Yeah, we divide the task in the group, then we gather as much info for the particular part and we just directly come out the thing and the description. And one people do the design and compile all this.
All this graph.
Is everyone okay for here? Aya, Aisha, okay.
Yeah. Okay. I think doctor just this assignment is only 2 pages, right?
Yeah.
One for the data and the other one for the description.
Yeah.
So like for the description, just like short description lah kan?
Yeah, just like satu ayat. I think if you do know how to describe your data, you can refer to the lecture note of Dr. Share, right? I think topic 7 or 8, it got about the case studies one. It got Dr. got share us about the data, the graph, and beside the graph for some description, we can may refer the way the doctor describe to us, explain to us. Yeah.
Okay.
Any other questions? Aisha and Arya got any questions? No. So we divide the task in the group and then compile. You guys think we need to have another discussion section or enough just like this?
I think enough.
Because if we did just it's gonna be
Okay,
confusing.
right? Yeah, okay, right? Yeah. So we just we divide the task and everyone do the best for their respective part and one person check, compile and design. Alright. Okay.
So for the submission, for the due for our group?
I think Saturday Friday night okay or Saturday morning because we need time to
The
design.
submission is Saturday. When
Sorry.
is the submission? When is the submission? Is it
Uh,
on
12
Saturday?
a.m. 7.
So it's Friday night or what?
Saturday night.
Saturday night.
Saturday night. We must submit it before 12 a.m. before the midnight. Yeah. So we have come out this thing on Saturday.
Yeah, Saturday morning maybe.
Okay, Saturday morning.
Maybe Friday,
night.
Friday night.
Yeah.
because one person need to compile, right? So I think it
Yes,
will
and
take time.
design I think is very time consuming for design thing. So Friday night I think better. No much thing, right? Just a small part graph and some short description only. So I think it's okay.
All right.
Guys, if we take the picture from the journal, do we have to like mention the source or
Side
claim?
Reference, I think no need, right? Because
because
it's
two people will take
hyperethical, we crack ourselves, so I think no need reference.
Okay lah.
Yeah, okay. So any other questions? No question, right? So if no question, it just end our meeting.
All right.
Thank you.
Okay.
Thank you.
Thank you all.
Bye bye.
Bye.
Bye bye.
And how to score? Oh.